All right. So, hello, grade nines. This is Mr. Musklo, and this is a video that I have made just for you. And this is actually a video that I am going to publish on YouTube, just because YouTube videos are easily accessible. That'll make it easier for the supply to play it, and even if students miss class and want to watch the video since they missed class, you can also see the lesson today. So, right now, as I record this video, it's Thursday evening. So, whenever you watch the video, this is now yesterday evening. And as you know, I was away on Thursday because I wasn't feeling well. And the rules, as we know, are if you're feeling sick, you're supposed to isolate. And I also just wanted to take the day on Thursday to rest up. So now it is Thursday evening, and I am feeling better. And so I was feeling up to recording this video. But I won't be in on Friday. I will be continuing to isolate on Friday because the rules are you're not supposed to return to school until it's been at least 24 hours since your symptoms have started improving. And it wasn't really until this evening that I started to feel better. So yeah, I won't be in on Friday. And so I figured, since I'm isolating on Friday, that it'd be helpful for me to just record a video that explains some of today's material. And so that's really kind of the purpose of this video. The lesson in this video is called Getting Chemistry Terms Straight. And you can see in the opening slide, it says this is an original Mr. Musklo lesson. You won't actually find this anywhere in the textbook because I just put this lesson together myself. In this PowerPoint, we're basically going to get straight what the difference is between some chemistry terms that are often confused. So students will often use chemistry terms like compound or molecule interchangeably. But we're going to see in this lesson that there really is a difference between these terms. And so we're just kind of going to get into the nitty gritty in this lesson of what the difference is between some various terms that are commonly used in chemistry. Okay, so we'll just get into it then. We'll start off with atoms. Okay, we'll be very thorough here. I'm sure that we probably all know what atoms are, but we'll just make sure that we're clear on all this. So we've seen already that atoms just consist of a nucleus with electrons moving about around it. So this is our picture of the atom. We have our nucleus in the middle with electrons moving around. And the nucleus, we know, is made of protons and neutrons. Okay, so that's what an atom is. In our classroom at school, there is, of course, a periodic table of the elements. And so that periodic table lists all 118 elements that are currently known. Okay, and we've learned already that each element on the periodic table is defined by the number of protons that are in the nuclei of its atoms. So if I just zoom in on our periodic table here. All right, so we can see that all of the elements on our periodic table are numbered. And that number tells you how many protons are in the nucleus of an atom for that element. So for example, neon is number 10 on the periodic table. And so this means that if you have an atom that has 10 protons in its nucleus, that is a neon atom. Okay, and then if you had an atom that had, let's say, 6 protons in its nucleus, that would be a carbon atom, because carbon is number 6 on the periodic table. Okay, and so the periodic table, of course, it lists 118 elements in total. Um, Only about 90 or so of those elements actually occur naturally, though. And this is a point that I've made many times in this chemistry unit. I will use this video as an opportunity to make the point again. Um, Elements can't be broken down into anything simpler chemically. And so this means that elements really are used to build everything. The elements bond together in various combinations to produce everything in this picture. So the materials that make up the planet Jupiter, these are made of atoms of the various elements bonding together in various combinations. Everything in the ocean, anything that you see in this picture of the forest, it really is all made of these elements. And that's really just quite amazing that, you can look at the periodic table and really see what everything is made of. But that's really kind of the amazing thing about chemistry. Now, in the rest of this PowerPoint, we're kind of going to get straight what the difference is between terms like compound, molecule, and we're going to see things like formula units. We'll start out with a compound. So, a compound is simply a substance that contains two or more elements bonded together. So, water is an example of a compound. Okay, chemically, we've learned that water is H2O. And it's a compound because it's made of two elements, hydrogen and oxygen. And hydrogen and oxygen bond together to form H2O units. Okay, and so this is our H2O unit. And that's really what water is chemically. So it's made of two elements bonded together. Now, sodium chloride would also be an example of a compound. It's also made of two elements. So it's made of um, sodium and chloride ions. It's formed when sodium and chlorine bond together. Okay, so water and sodium chloride, they're both compounds because they're made of two elements. And of course, other compounds are made of more than two elements. And now we've learned in our chemistry unit that there's two main types of chemical bonds, these being ionic bonds and covalent or molecular bonds. And this distinction becomes important when we talk about molecules and ionic compounds. So, a molecule only contains covalent or molecular bonds. Okay, an H2O unit is an example of a molecule because it only contains covalent or molecular bonds. Okay, and we learned, of course, that covalent or molecular bonds form whenever atoms share electrons. And so in our water molecule, we have a hydrogen atom and an oxygen atom sharing a pair of electrons to form a covalent bond between them. And so there are two hydrogen atoms bonded to an oxygen atom in a water molecule. Okay, and chemically, liquid water is just made up of a bunch of these H2O molecules. So that's what a molecule is. It has covalent or molecular bonds. Now, ionic compounds are different. They contain ionic bonds instead. Okay, and so we have learned how ionic bonds form. This image shows an ionic bond forming between sodium and chlorine. And so whenever sodium chloride forms, right, our sodium atom gives an electron to a chlorine atom. Whenever the sodium atom loses an electron, it becomes a positively charged ion. And when the chlorine gains an electron, it becomes a negatively charged ion. And the ions formed here have opposite charges, and opposite charges attract. And that really is what causes the bond in an ionic bond. It comes from the fact that the ions are attracted to each other. Okay, so sodium chloride is an ionic compound. It's not made of molecules because molecules contain covalent or molecular bonds. Okay, and I'm going to return to that idea later in the lesson. Actually, I'm going to return to it right now. So yes, it's important to understand that there is no such thing as a sodium chloride molecule. Okay, molecules only have covalent or molecular bonds. And it's important to not say that uh, that sodium chloride is made of molecules, because in an ionic compound, there really aren't any set of ions that you can identify as being separate from the other ions. Okay, and to just make this idea a bit clearer, I just have an image of our sodium chloride compound, and I have it opened here so that I can draw on the picture. Okay, so what's going on here? Well, this is a sodium chloride crystal. And so you can see that basically we have sodium and chloride ions arranged into kind of like a cube shape. It turns out that sodium chloride chemically really is made of ions arranged in these sorts of patterns. And the reason why the ions arrange themselves in this way is because the ions have opposite charges. Okay, and so you can see that our sodium ion in the center here is surrounded by chloride ions. And they arrange themselves in this way because the sodium ion is positively charged and it's surrounding itself with chloride ions that are negatively charged. Okay, so we know that opposite charges attract. This positively charged sodium ion is going to be attracted to negatively charged chloride ions. And so that's why our positively charged sodium ion surrounds itself with negatively charged chloride ions. Okay, and similarly, if you look at every chloride ion in this structure, it is also surrounding itself with ions of the opposite charge. So it's also surrounding itself with positively charged sodium ions. Okay, so in this crystal, we just basically have the ions arranging themselves in a particular pattern. And so you can't really point to any two um, ions in this crystal and say that these two ions are separate from the others. For example, right, let's say that I wanted to call this sodium chloride unit a molecule. That's kind of a no-no because this unit is not really separate from the rest of the crystal. Um, Someone else could just as easily say that this instead was a molecule. Okay, and so you can kind of see the difference between an ionic compound and molecules. In a sample of water, for example, these H2O units really are separate from each other. Okay, so each of these molecules consist of an atom of oxygen bonded to two atoms of hydrogen, and each of these molecules are separate from each other. Okay, but the story is different with our ionic compound. You can kind of see in a way that all of the ions are kind of bonding together in this crystal. And so it's incorrect to say that a sodium chloride unit here is a molecule because they aren't really separate from the rest of the crystal. Okay, and that is kind of an important idea that I hope we take away from this, is that we shouldn't be calling ionic compound units molecules. That's kind of a chemistry no-no. Okay, and so this means that the formula NaCl does not tell you that the substance is made of individual NaCl molecules. All it's telling you is that the sodium and chloride ions are in a 1-to-1 ratio. So, in other words, for every one sodium ion, there is one chloride ion. Okay, that's what the formula NaCl says. Okay, and then you might wonder, well, how could we have an ionic compound where the ions are not in a 1-to-1 ratio? Well, I'll show you an example. We did actually see this example in our lesson on ionic bonding. Aluminum chloride has one aluminum ion for every 3 chloride ions. So what takes place with aluminum chloride is you have an aluminum atom that has 3 electrons in its outermost orbit. Okay, and then every chlorine atom is only looking to gain 1 electron to complete its outer orbit. So the arrangement in aluminum chloride is 1 aluminum atom gives its 3 electrons to 3 chloride ions. And so this is an example where the ions are not in a 1-to-1 ratio. Instead, there is 1 aluminum ion for every 3 chloride ions. And so a crystal of aluminum chloride would kind of look like this instead. Okay, so you can see that for every 1 aluminum ion, which is kind of this, I don't know, I guess beige color, there are 3 chloride ions shown in green. Okay, and in this entire picture, there are 2 aluminum ions and 6 chloride ions. Now, the last term that I would like to just define for all of you is the term formula unit. So a formula unit is the smallest unit in an ionic compound that has the ions in the correct ratio. And so to just show you how that works, I'm actually going to go over to my other desktop here so I can circle stuff again. An example of a formula unit would be just 1 NaCl unit in the sodium chloride compound. Okay, so what I've circled here is a formula unit. This is the smallest possible unit that has the ions in the correct ratio. And the formula NaCl is telling you that the sodium and chloride ions are in a 1-to-1 ratio. So the formula unit just has 1 of each ion. Okay, now for our aluminum chloride compound, one of its formula units would just consist of 1 aluminum ion and 3 chloride ions, because the aluminum and chloride ions are in a 1-to-3 ratio. So I'll just circle a formula unit of aluminum chloride. Okay, so that's what we mean by formula units. You might be tempted to call these things that I've circled molecules, but since these are ionic compounds, they are not molecules. Okay, so that is the end of the lesson. And you'll see that the last slide is just some questions for you to answer. So kind of like we would do in a normal lesson, now that I've gone through some PowerPoint slides, you can just spend some time answering these questions. As I said earlier, this material is not in the textbook, so I couldn't really find any textbook questions that really asked what I would want to ask. So I just made these questions myself. So perhaps your supply teacher can just leave this slide on the Spark board so that you can see the questions as you work on them. And yeah, we'll take up these 3 questions whenever I see you all next, which I feel quite confident will be on Monday, I hope.